Oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, good afternoon, dear invited speaker and presenters. We thank you for your presence and willingness to present this result in the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, or ICRMCE 5, with the theme Advanced Research Anthology for Rehabilitation and Maintenance in Civil Engineering through Online Media. Salam sejahtera bagi kita semua. Salam, Namo Buddhaya, Om Swastiastu. Hopefully the COVID-19 pandemic can end soon, so that we can meet in person to exchange ideas and conduct research collaborations. Okay, in this presentation session, for invited speaker session, the maximum presentation time is 15 minutes, and the questioning time is maximum 5 minutes. On the first occasion, we invite Dr. Erwin Lim. Good afternoon, Mr. Erwin Lim.
Good afternoon.
As invited speaker for the Class B Paralel session with the paper title, Role of Diagonal Bars in Reinforced Concrete Deep Beams Tested Under Static Load. Previously, I will read the curriculum vitae from Dr. Erwin Lim. 1 minute. Okay. Name Dr. Erwin Lim from MC. Office CB Building, Civil Engineering Department, Institut Teknologi Bandung. Jalan Ganesha, number 10, Bandung, Indonesia. Education background, bachelor's degree program from ITB, Institut Teknologi Bandung, 2005. Master's degree, National Taiwan University, 2009. And National Taiwan University, doctoral degree program, 2015. Experience, 2018 until now, assistant professor at Department of Civil Engineering, ITB. 2017 until 2018, course tutorial instructor, Maranatha Christian University. 2020 until 2025, member of Technical Commission for Development of National Standard, SNI 91-06, 2018 until 2019, Secretary of Team, SNI 1726-2019, National Standard for Seismic Design of Structure. 2019, member SNI 2008-47-2019, National Standard for Building Code Requirement for Structural Concrete. Membership, Secretary of Indonesia, Association of Earthquake Engineering, Asosiasi Ahli Rekayasa Kegempaan Indonesia, member of American Concrete Institute, member of HAKI, Himpunan Ahli Konstruksi Indonesia. Several papers that have been published are those written below, and of course many more. Okay. To Dr. Erwin Lim, time is yours.
Thank you for your introduction. I think I have to send the video. Will the committee
Okay.
play the video or not?
Please, MC, display this.
Hello, ladies and gentlemen. It's my honor to present my research entitled Role of Diagonal Bars in RCT Beams Tested Under Static Load in this fifth ICRMCE. My name is Erwin Lin, and I come from Institute Teknologi Bandung. This research was actually carried out by myself and my student, Mr. Rahmat Ramli. This research was funded by ITB under P3ME program in 2018. First, let's talk about the background. First, we would like to investigate the role of the diagonal bars or its beneficial effect. As we know that the diagonal bars is widely used for coupling beams because it's very good for the energy dissipation and ductile behavior needed for the seismic design. Secondly, we tried to search in the literature, and similar use of diagonal bars also occur in Corbel. This is in 1996 by Professor Foster. However, our literature didn't show that the application of diagonal bars for deep beam. Therefore, we would like to see if the application of diagonal bars in deep beam will reach similar behavior with that in Corbel and in coupling beams. Secondly, we would like to investigate the discontinuity effect. In construction practice, the force is transferred through the column stop. Therefore, the proper modeling in the laboratory should be using the column stop. And if we load the column stop, then the discontinuity is due to the geometry. And the crushing of the concrete can be seen occur at the stop vicinity. However, in the literature, we often see that the researchers load the force using the bearing plate. And if they use the bearing plate, then the discontinuity change from geometry to the force discontinuity. And it also affects the behavior somehow. As we can see in here, the crushing shifted from the vicinity to the under the bearing plate. Therefore, our second objective is to study the effect of discontinuity modeling. This is our test setup in ITB. So we have the actuator here, and then it spread it to the beam using the very stiff steel beam. Totally, we have 4 specimens, 2 with column stop with C and 2 with bearing plate with B. For column stop, we have 0 is without diagonal bars and 2 is with diagonal bars. All 4 specimens possess similar ICRMCE, around 20 MPa, similar span to depth ratio, 1.56, and similar flexural reinforcement ratio, 1.73%. For specimens without diagonal bars, we purposely designed these specimens to fail in shear. And without changing the reinforcement ratio, we simply add 2 diagonal bars, 2 D16 diagonal bars. And our hypothesis is that we can change the failure mode from brittle shear to the ductile fracture behavior. This is the results, and we try to see the effect of this continuity modeling first. Here we can see the difference of the load deflection curve for specimen under column stop and bearing plate. We can see that the specimen with column stop, it has the higher load. Why is it? Our hypothesis is like this. So if your specimen is using bearing plate, then it should be bounded by the force discontinuity. Therefore, your LH is from here to here. It's longer. However, if you are using the column stop, then the discontinuity is bounded by the geometry. Therefore, your LS is measured from here to here. Therefore, your LS is shorter. Under the similar LV, your inclination angle of strut for specimens with column stop is higher than that of the bearing plate. Therefore, therefore you have the higher load. Similarly, we can also observe for specimen with diagonal bars, although not so significant. For specimen with column stop, it also has a slightly higher load compared to the bearing plate. The reasons why this is not so significant is because the geometry, the failure is governed mainly by the flexion. Secondly, let's see the effect of diagonal bars. We can see that whether or not they are column stop or bearing plate, with the additional of diagonal bars, it shifted the load deflection curve from the ductile shear behavior into a ductile flexure behavior. Although we observe some yielding of the reinforcement for the specimen without diagonal bar, however, this does not last long. The reason being like this. So under the similar flexural strength, specimens without diagonal bars, we can only count on the concrete to resist the shear strength, as shown in this equation. However, if you have diagonal bars, then we can count on additional contribution from the diagonal bars. So the sign, the vertical component from the diagonal bars is also very significant here. Therefore, you can have higher shear strength for specimens with diagonal bars. Therefore, you allow better development of its full behavior. Next, we try to use strength and type modeling to estimate the strength. As we know that for the strength and type modeling, we estimate strength of the 5 location, strength of the strut at top and bottom, strength of the nodal zone at top and bottom, and strength of the tie. Here, we try to modify a little bit the ACI strength and tie modeling. For specimen with column stop, the strut area is modified as shown in this figure. So we don't account for the column stop in here because it's bounded by the geometric discontinuity. However, if this is bounded by the force discontinuity, then we account for the half of the width of the bearing plate to calculate the strut area. So this is the main difference. Let's see the result. So here is the test value. So it should be divided by 2 if we want to compare with the strut and tie results. And we can see that for the strut and tie result is taken as the smallest between the strength of the strut, nodal zone, and tie in here. Okay. And we can see the strength ratio is 2, 1.55, 1.59, 1.32. So overall, the average is 1.62 and COV is 0.18. So we can argue that this result is quite conservative, but it's actually have a good COV. And we can also see that the failure mode predicted is more or less similar with the test value. So here we have flexural shear behavior, we have the upper strut crushing. But if you have diagonal bars, then we can have diagonal flexural behavior in the test. But still in the predicted value, you have the upper strut crushing and the tie yielding here. So some modifications for the strength modeling may be needed in the future. So after all, our conclusion is like this. We agree that the diagonal bars increase the shear strength of the tip beams. Therefore, it will alter the failure mode. It allows a better development of the flexural behavior. Secondly, our strength and modeling need to consider this continuity effect, whether it is force or geometric discontinuity. And if we'll take this into account into the strength and modeling using the ACI 318, then it still can provide conservative estimation. Thank you for your attention. Hopefully it's quite clear. If there is any question, please, or anything to discuss, I will appreciate that. I think Dr. Putra, you are still mute.
Okay, sorry. Okay. Complicated and expensive research. Interesting and good topic. Are there any questions from this presentation?
There is one in the chat room.
Hello?
From Mr. Ibnu.
Mr. Ibnu, okay.
Okay.
Is there any difference if it's applied in the core wall, or what are the considerations?
Okay, thank you for your question. If it is applied in the core wall, then usually we call it a coupling beam, not a deep beam. So the consideration is that for core wall, we expect it will be subjected to earthquake loading, which is a cyclic. So it can be alternate direction. So we need the diagonal bar not in only one direction, but in two directions. So it will be just like an X. Yeah. So it's very common in the application of core wall in coupling beam. Hopefully it answers your question.
Okay. Mr. Ibnu Shamsi.
Yeah, okay. Thank you very much. That answers.
Okay, thank you.
Yeah.
Any question from this participant? Other participant? Okay, this is a simple question for Mr. Edwin. Where was the research conducted?
It's conducted in the structural laboratory of ITB.
Oh, ITB. Oh, okay.
Okay.
Good.
It's actually an old lab. Currently, we have a new lab with a more with a better equipment. But
Okay.
unfortunately, due to COVID, we cannot do anything.
Okay.
Yeah.
Any question? Okay. From Muhammad Yani.
Yeah, Pak Yani.
How about the use of high strength steel for those diagonal rebars? Oh, good question. Okay.
Yeah, thank you for your question, Pak Yani. Long time no see. The use of high strength diagonal bars is also possible, but we have to watch out whether or not the reinforcement can reach yielding or not. Because in the equation, we always assume that the diagonal bar can yield. But in the actual application, it may not yield. Maybe the concrete crushes first before it yields. So therefore, we need to consider the different effect. Yeah. Hopefully, it
Okay, Mr. Muhammad Yani. I see. Okay, thanks. Any question? Okay. There's no question from other participant? Okay,
All right, so if you have
wait,
other question, you can email me.
About 5 minutes or 2 minutes. Mr. Erwin Lim, maybe
Yes.
You can sketch the use of high strength steel from this diagonal rebars.
I beg your pardon?
You can do it. Sketch the use of high strength steel for those diagonal rebars.
Okay.
Okay.
No problem.
Sorry.
I cannot sketch from here.
Oh.
Usually it's using the annotate, but I cannot find the option here.
Oh, okay.
But let me share. Oh, I cannot share screen as well. So could I share screen to the committee?
Please, committee.
Okay. Okay. So basically, if you use high strength steel bar, then the layout is still the same. That you have to use put it like this in the diagonal directions. Okay. And if it is subjected to cyclic loading, then you have to put it in two directions like an X.
Oh.
But one thing that we need to watch out is for the equation. Let me show. Okay, here. In here, we can see that the contribution of diagonal bar is using the area times the yielding strength of the diagonal bar. So the high strength steel bar may reach up to 680 MPa, right? So if you use a very low quality concrete, maybe 25 MPa or 30 MPa, maybe the concrete will crash first before it yields. Therefore, if you use this equation, it may not be appropriate.
Okay.
So if you use high strength diagonal bar, then maybe you also need to use high strength concrete.
Okay.
So that they are compatible. Something like that.
Okay. We can use steel profile like CNP or WF or profile H.
Yeah, I think it's possible. It's
possible. Okay.
In the coupling beam, sometimes they use also a strength profile. So we have a like this is the wall. This is the wall, right?
Okay.
This is the wall,
and
then they use steel plate like here.
Steel plate.
Steel plate, and then here they put a lot of shear connector inside the wall, something like this, so that it will be integrity between the wall and also the steel plate coupling beam. Yeah.
Okay.
This is also a possible layout. Yeah.
Thank you, Mr. Erwin. Lim.
Thank you.
Okay. If there are no more questions, we can conclude the presentation session by Mr. Erwin Lim.
Thank you.
Thanks to Mr. Erwin Lim for your presentation. Good presentation, good topic, and big. I hope give benefit for construction behavior. Okay. Furthermore, in this presentation session, for each session, the maximum presentation time it's 8 minutes, and the discussion questioning time is maximum 4 minutes. Dear participant, Mr. Aji Putra Abrian, Mrs. Surya Dewi Puspitasari, Mrs. Diah Ayu Pangastuti, Mr. Joni Tanijaya, Mrs. Isyana Ratna Hapsari, Mr. Hakas Prayuda, Mrs. Ida Nomleni, Mrs. Fatia, Mrs. Florentina. Are you present now? Okay. On the second occasion, we invite Mr. Aji Putra. Mr. Aji Putra?
Yes, sir.
Okay. As the first presenter for the Class B parallel session with the paper title Experimental Investigation on the Shear Behavior of Patch RC Beams Without Web Reinforcements, Efficacy of Patching Position with Respect to the Shear Span. Okay, Mr. Aji Putra Abrian, time is yours.
Yes. Hello, ladies and gentlemen. I hope you all are fine. Before telling you more and more, let me introduce ourselves. My name is Aji Putra Abrian as the first author, with the corresponding authors are Stefanus Adi Krisdawan and Halwan Alfisa Saifullah. And the other authors are Muhammad Rafi, Muhammad Hafiz, Andre Simanjuntak, and Abi Abismo. We are from Civil Engineering Department of 11 Mart University, Indonesia. The one I want to start to you all today is about Experimental investigation of the series behavior of patch RC beams without weight reinforcements, efficacy of patching position with respect to the series span. As for the scope of discussion that I will present, first introduction, second experimental program, third behavior of test specimen, and fourth conclusion. Introduction. A reduction in the shear capacity of RC beams. One type of the damage often found in RC beams element is spalling of concrete covers. The damage of spalling a concern about the structural component safety, especially when it occurs within the shear span of the beam. If spalling is not repaired, it will unconservative the capacity of the beam. Shear failure is more dangerous than lateral failure because it typically occurs unexpectedly. Christian et al. 2017 to recover the shear capacity of the damaged RC beams using UPR mortar. The research showed that the shear capacity of the patch RC beams can be increased. Furthermore, the effective contribution of UPR mortar to interfering with the propagation of diagonal cracks is location dependent. Next experimental program. The beams were made of ordinary concrete with material specification as follows. Next specimen of beam. 3 different types of RC beam specimen with a shear span to effective depth ratio of 3 were prepared and tested, among other things, namely, first, MC, as a control beam without patch repair. Second, PR1, as a patch RC beams with patching position at 0.25 of the shear span. Third, PR2, as a patch RC beams with patching position at 0.5 of the shear span. Next, this is the setup of the beam testing. Next, behavior of test specimen. The failure mode. For all RC beams, the maximum longitudinal reinforcement strains at ultimate load did not exceed the reinforcement bar yield strain. The failure mode of all beam specimen is typical of diagonal tension. After the initial diagonal cracking formation, which indicated the beginning of shear crack, the patch RC beams resist more shear force accompanied by further development of shear cracks. And next, crack pattern sketch from MC beams. The flexor cracking capacity was at 30 kN. The significant diagonal cracking load was at 86 kN, and the ultimate load occurs at the same load that was 86 kN. The flexor cracking capacity was at 30 kN. The significant diagonal cracking load was at 110 kN, and the ultimate occurs at 120.4 kN. And next, crack pattern sketch from PR2 beams. The flexural cracking capacity was at 35 kN. The significant diagonal cracking load was at 95 kN, and the ultimate load occurs at 101 kN. And I will extend the mechanism of the crack pattern on each specimen. In the MC beams, a continuous propagation of the diagonal crack is observed from the lower surface of the concrete toward the loading point. While on the PR1 and the PR2 beams, the presence of UPR mortar could resist the diagonal crack propagation. The resistance against the propagation of diagonal crack by the patching material causing an improvement in the shear resistance of patch RC beams. And then for efficacy of patching position, the contribution of UPR mortar has significant effect in resisting the diagonal crack to preserve the compression zone at a high load level when it is the repair material close to the loading point. Next, load deflection response. You can watch it on this chart. The influence of patching repair becomes more pronounced after the first flexural cracking occurs, with MC beams having the most significant decrease of thickness reduction. The PR1 beam with a patching position at 0.25, the shear span show the largest shear capacity is 40% higher than the control beams. And next, diagonal crack. The highest tensile strength of the patch repair material effectively prevents the diagonal crack from propagating. Consequently, the beam holds a sufficient compression zone to provide a considerable lateral compression zone. Furthermore, in the diagonal crack beam, the uncracked UPR mortar provides slip resistance promoting aggregate interlock on the surface of diagonal cracks and improving of the aggregate interlock. Next, conclusion. First, the uncracked feature of UPR mortar affect the shear transfer mechanism by arresting diagonal crack propagation and providing slip resistance. Second, the closer the UPR mortar to the loading point will be more effective in preserving the compression zone, thus increasing the shear strength. Okay, thank you so much for your attention.
Okay, thank you, Mr. Abrian, for your presentation.
Yes.
Interesting and good topic. Are there any questions for this presentation? From participant?
I think there is one in the chat room.
Hello? Okay. Dear Mr. Aji, what are the considerations for PR1 and 2 placement?
I think he is typing the answer.
Yeah, sorry.
You can just answer verbally.
Okay, thank you, Ms. Isyana. I can answer this question. The only consideration is to effect of placement, whether placement closer to the loading point is better in resisting shearing. Because they have two type consideration for PR1 and PR2 placement, because the pitching location also affects the extent of the propagation.
Mr. Abrian can display from slide.
Okay. Yes, it is the basis of EPR mortar that resist the diagonal crack propagation. The resistance against the propagation of the diagonal crack by patching material causing an improvement in the shear resistance of patch RC beams. And then efficacy of patching position, that the contribution of EPR mortar significant effect in resisting the diagonal cracks to preserve the compression zone at a high load level when this repair material close to the loading point. Yes.
Okay. Mrs. Isyana Habsari. This answer from your question. Okay. Other participant? Question?
May I?
Okay.
Okay,
Please,
thank
Mr.
you.
Edwin Lim.
Thank you, Mr. Haji.
This is similar for your research.
Yes, yes. I like the shear topic a lot. So I'm very happy to see your result. But a little bit of discussion. You mentioned that the patching is very good to have the VCY, right? is the contribution of concrete in the compressor zone, is it?
Yes.
But on the other hand, you mentioned that your specimen failed in diagonal tension. Diagonal tension, in my understanding, is like a aggregate interlock. So it's kind of like different location. So any opinion about this? Thank you.
Okay, that's my opinions. The presence of patching can influence the shear transfer mechanism. The high tensile strength of the patch repair material effectively prevents the diagonal cracks from propagating, and consequently, the beam holds a sufficient compression zone to provide a considerable PCY. And furthermore, in the diagonal crack beam, the uncracked EPR mortar provides slip resistance, promoting better aggregate interlocks on the surface of diagonal cracks and improving PCY. Thank you.
How much is the ratio of your flexure reinforcement?
What?
Ratio.
The ratio of flexure reinforcement.
3.
Huh?
From your enforcement. Ratio reinforce.
Ratio reinforce. Oh, sorry. So, sorry, I forget. Yes.
Oh, it's okay. Never mind. Yeah. Thank you.
Yeah, you're welcome.
Okay. Any question from other participant? Okay. Thank you. Thank you, Mr. Adrian, for your presentation.
Welcome.
It's good presentation and good topic. Thank you. On the third occasion, we invite Mrs. Surya Dewi Puspitasari as the second presenter for the Class B parallel session with paper title A Critical Review of Bridge Management System in Indonesia. A good topic. Okay, to Mrs. Surya Dewi Puspitasari, time is yours.
Hello everyone, my name is Surya Dewi Puspitasari, and today I would like to present my paper review which entitled A Critical Review of Bridge Management System in Indonesia. Let's start from introduction first. Indonesia has been becoming the world's 10th largest economy and the most enormous economy in Southeast Asia. This condition is encouraging Indonesia's infrastructures to grow rapidly, and now Indonesia has at least 18,000 existing bridges in 2019, which were reported 14% in unhealthy condition. But unfortunately, the implementation of IBMS in Indonesia is still poor, and it has caused some bridges were damaged and collapsed during their service life. For example, the collapse of Kutai Kartanegara Bridge in 2011. On the other hand, the US and Japan, as developed countries, have expanded their BMS through Federal Highway Administration and Ministry of Land, Infrastructure, Transport and Tourism, respectively. Our neighbor, Thailand, the same as developing country as Indonesia, has also established a bridge maintenance management system in 2012 to undergo the periodic bridge inspection and maintenance program. Therefore, to enhance the IBMS implementation in Indonesia, the authors write this paper to increase the awareness raising of the IBMS implementation in Indonesia by seeking for and integrating the existing bridge management system that has been established and implemented in the US, Japan, and Thailand. So this is the development of bridge management system of each country. Start from the left one, this is the development of BMS in the US. They made National Bridge Inspection Standard in 1971, soon after the Silver Bridge collapsed in 1967. And then they also developed Pontis. Pontis is a tool or a software that helped the authority to do monitoring and also to make a decision to do maintenance work or not. And Thailand actually has already formed a BMMS since 1989, but at that time they only applied this system for 10,000 bridges with without bridge maintenance in rural areas. So in 2013, they made new manual bridge maintenance in rural area. And Japan, they have Japan's specification for highway bridges since 2001 and manual for bridge periodic inspection since 2014. And Indonesia, we have interurban bridge management system since 1993, and we made it with Australia. So why does IBMS implementation in Indonesia still poor? There are at least 3 factors that made it. First, scarcity of funds, limited of funding. The budget allocation from government cannot cover all the bridge maintenance costs. And second is insufficient human resources. So we don't only lack of number of people, but we also lack of certified and qualified bridge inspectors or maintenance engineers that expert in bridge management. This factor lead to the ignoring standard because lack of certified and qualified it means that lack of knowledge, and it leads to misconduct in maintenance. So ignoring standard is very possible. So how to improve the IBMS implementation in Indonesia? We propose to do bottom-up approach. So the proposed strategy cost is compared to the budget to accommodate the standard and customized strategy. So we made the strategy, we made the cost, and then we compared with the budget allocation that we have, and then we can accommodate the standard. So we still can do maintenance work according to the standard, according to the manual, but with different strategies. And the second is we need to have optimization of the bridge maintenance model with 3 factors that at least need to be considered. First is structural performance. It relates to the safety of the bridge. It's very important. And the second one is life cycle cost. LCC is related to the economy, and also NBV is related to the economy. So how to make an optimum maintenance strategy that can make optimum structural performance and with minimum life cycle cost and with the maximum NBV. And this is at least 6 recommended aspects from BMS implementation in the US, Japan, and Thailand. First is life cycle costing. It's about cost model. And the second is risk, the collapse effect and possibility. And third one is degradation model to forecast the structural condition. Degradation model relates to the life cycle costing. If we have degradation model to forecast the structural condition, the deterioration mechanism, so we can make the life cycle costing, we can make the cost model. And then effects of maintenance work, the improvement works after the bridge has already gotten the repair actions. And then safety, we need to ensure the safety. So we need to know the probability of failure to ensure the safety, to ensure that the bridge is safety. It's for social. And then to optimal maintenance strategies, it's optimization model for maintenance cost repairing and rehabilitation works. So we can do maintenance work within budget limit. But not all countries apply the proposed aspects that I mentioned before. For example, Thailand, they apply all the aspects that I mentioned before, but for US, doesn't apply life cycle costing. But Japan does and Thailand does. For Japan does not apply the optimal maintenance strategies, but the US does, the Thailand does. So the conclusion from this paper is first, making optimization of the bridge maintenance model with the structural performance and economic consideration is highly required. Second, improving and updating the procedure and the standard quality as well as the training for bridge inspectors and maintenance officers is necessary. And third, having more detailed and comprehensive information for some aspects in IBMS, for example, safety, risk, degradation, effects of maintenance work, and etc., that are expected to be able to define and apply for optimum maintenance works within budget. Thank you for listening. Any question?
Okay, thank you, Mrs. Surya Dewi Puspitasari. Okay. Where do you come from? Uh, from 11 Maret or
Me?
yeah.
I'm from Universitas Pertahanan, Indonesia Defense University.
Okay, Jakarta.
Sentul actually.
Okay. Okay. This question from Mr. Ibnu Samsi. Dear Mrs. or Mrs. Miss or Mrs. Miss. Okay, sorry.
It's okay.
Miss Surya Dewi. How do you think about bridge management system in Indonesia? Second question, which part should be improved first?
Okay, thank you very much for the question, Mr. Ibnu Samsi. Okay, I'm gonna try to answer the first question first. So, in my opinion, I think BMS in Indonesia is still, how do I say? The application is still poor, especially about the maintenance. So, if I when I look into the how do I say the manual book of IBMS, in the manual book they still use the old, it's still using old manual. I mean, the manual was made in 1993, around that time, 1992, and we still use it till now. It's already more than 20 years. I think more than 20 years. And I think it relates to, it will answer your second question. So the first thing that we need to improve first is the manual. I think we need to update the manual first. Is that
okay, Mr. Ibnu Samsi?
Yeah, I got it. I got the idea.
Okay. Any question from other participant? Maybe from me.
okay?
There are 3 questions
Okay.
for Miss Surya Dewi.
Okay.
How many years was this research conducted? Second question, how to determine that 14% of breeds in Indonesia are in an unhealthy condition? And last question, how to analyze the life cycle cost of breeds in small areas that are intended as a connecting medium between villages?
Okay, thank you for the questions. I'm gonna try to answer the first question. The first question is how many years?
Okay, was this research conducted?
Honestly, this research was maybe only about 1 month.
Okay.
So yeah, that's why I did only a review. Actually, it's only review.
From literature review or direct observation? From literature review or
it's from review. Yeah.
Literature review.
Yes, it's paper review. And about your second question, how did I know that there are 14% bridges in Indonesia is in unhealthy condition? It's based on the statistic information, like statistic information book from Ministry of Public Works. So they launch the statistic information annually. So I knew from that books.
Okay.
And about third question,
how to analyze the life cycle cost of breeds in small area that are intended as a connected medium between villages?
How to analyze? So for life cycle cost,
I think that based on my experience, actually, I never analyzed bridge, but
Okay.
I ever did it for port structures, especially wharf. And to analyze it, usually first we need to know the initial cost first, because this is life cycle cost. So we need to know the initial cost of the bridge. And then the second is we need to know what kind of maintenance, repair, or maintenance strategy that we will do to that bridge. And of course, we need to do inspection. However, if the bridge is in small area or the medium area, maybe life cycle cost will be too much.
Okay.
Yeah.
Okay, thank you.
You're welcome.
Okay, any question from other participant?
From
From
Mr.
Mr. Remir Joseph. Do you have a follow-up research for this topic?
Okay. Thank you very much for the question, Mr. Remir. So yeah, I do have the follow-up research for this topic. Actually, after I wrote this paper, I already wrote another paper, which it's more about the bridge inspection and the implementation. So it's still review paper. So I did the same. I still did the same comparison from bridge inspection and implementation in Japan, US, and Thailand and Indonesia. So, and after that, if it's possible, I would like also to make an, how do I say, like a model, like I said before, like optimization model for bridge management system that not only consider the structural performance, LCC and PV, but also if it's possible, we also need to consider the environmental issues, as we know that now the global environment is not in good condition because we are from construction works. So I think we need to consider about the emission, the gas emission, like CO2 emission, if this is possible. Is that
okay? Okay, thank you. Okay, time is up. Okay, thank you for your presentation. A good presentation, Ms. Surya Dewi Puspitasari. And next, on the fourth occasion, we invite, Mrs. or Miss Dia Ayu Pangastuti as the third presenter for the Class B Paralel session with the paper title Development of Simple Building Maintenance System based on WBS, Building Information Modeling, and Web to Improve Building Maintenance Performance in the Government of DKI Jakarta Provinsi. Okay, Miss or Mrs. Dia Ayu Pangastuti, time is yours.
Good day, ladies and gentlemen. My name is Dia Ayu Pangastuti from the Department of Civil Engineering, University of Indonesia. Allow me to do the presentation of my research as work together with Professor Dr. Insinyur Yusuf Latif MT as my supervisor. We have researched the development of preventive maintenance guidelines for simple classification government buildings based on work breakdown structure within the DKI Jakarta provincial government. As the agenda for this presentation consists of 5 sections, which are introduction, literature review, research method, result and discussion, and conclusion. The introduction. Jakarta, as the capital city of the Republic of Indonesia, has the highest population density in Indonesia. Therefore, in order to fulfill the duties as a public servant, the government of Provincial DKI Jakarta has owned 9,823 buildings that spread throughout the DKI Jakarta provincial territories. This building is to support community services for the citizens. 60% of them is classified as simple buildings. The data survey also mentioned the condition of the buildings that classified as well-maintained, need of repair, and heavily damaged. From the analysis of the data, it can be concluded that almost 40% of the buildings in the DKI Jakarta provincial government are not in a proper condition. As you can see on the screen, the graphic on the left shows that the simple buildings has more in number than non-simple buildings, which is identified as poor condition building. We gain information from the interview that there are several obstacles in the building maintenance within the DKI Jakarta provincial government. Some of these problems are the regulation has unclear guidelines, the maintenance still using conventional method, such as corrective maintenance, and etc. Based on the several literature studies, the preventive maintenance become one of the most influential factors to run the building maintenance system, as mentioned by Ayman Al-Shari and Waziri. The literature review. This is the brief literature review that had been carried out for this research. The simple building classification is as mentioned in ministerial regulation as the building with floors up to 2 floors and area up to 500 square meters. The work breakdown structure is described by PMI as a hierarchical decomposition oriented towards the work that the project team will carry out to achieve objectives. It's determining the entire scope of work on a project. The preventive maintenance is mentioned by Lee as the periodic maintenance, such as regularly measuring, analyzing equipment problems to avoid failure. The research method. This research has the independent variables, which are the work breakdown structure and the preventive maintenance guidelines. The work breakdown structure has type of work and work package as sub-variables, while the preventive maintenance guidelines has activities and schedules as variables. Each of them covers the 5 building elements, which are structural, architectural, mechanical, electrical, landscape, and housekeeping. And as for the dependent variable, the building maintenance performance has safety, health, convenience, and easiness as sub-variables according to the law. As the problem formulation of this research is how is the structure of a simple building's work breakdown structure, and how to develop maintenance guidelines for simple buildings within the DKI Jakarta provincial government. There are 2-stage analysis of this research using questionnaire to determine the simple building work breakdown structure and preventive maintenance. This study used the Delphi method, which involved expert respondents for every validation process. On stage 1, 7 expert technical staff within 5 to 15 years of experience were involved. And on stage 2, there are 5 experts in managerial position within 10 to 25 years of experience were involved. The result and discussion. The first stage of analysis is the validation of simple buildings work breakdown structure. The questionnaire is given with the choice of yes or no answer to the types of work package that appropriate with the simple building categories. The validation of acceptance were carried out if there were any yes answer as a mode. Each of building element is validated and obtaining 27 type of works and 176 work packages. After obtaining the result for simple buildings work breakdown structure, the next stage is identifying the activities and schedule of preventive maintenance. The activities and schedules are then compiled as a guideline, resulting 1,049 maintenance activities. This guideline is then validated using a questionnaire and deep interviews. From the deep interviews, it was found differences of opinions about several activities or schedules. The differences of suggestion are collected in a list and then analyzed and discussed further. As the result of the further analysis and discussion, several work activities need to be corrected and even eliminated. There were 66 activities corrected and 4 activities were eliminated. The correction obtained 1,045 from 1,049 maintenance activities. As the final result, the 5 yeses are obtained from 5 experts for the validation whether this guideline can be used as a simple building maintenance guideline within the DKI Jakarta provincial government to improve maintenance performance. As the conclusion for this research, the preventive maintenance guidelines can be prepared based on the identification using work breakdown structure, but cannot be equated for all types of building classification. In the same work package, there can be different activities or schedule for preventive maintenance activities. Work breakdown structure and preventive maintenance guideline can improve maintenance performance, although not directly because the maintenance performance is very dependent on the activeness and concern of the building manager for the maintenance activities. These activities can be developed for the budget plan by analyzing the budget requirements of resources and equipment. And this is the end of my presentation. Thank you for your time and attention.
Mic is still muted.
Sorry. Dear Miss Dia, are the literature you used to develop maintenance guidelines based on regulations? And what are the reasons for the corrected and eliminated activities?
Okay. Okay, I will try to answer. Thank you, Ms. Rizka. The first question, are the literature you use to develop maintenance guidelines based on regulation? Well, I use many references to make these guidelines, but there are 6 references that I use the most. And these 6 references have examined using the regulation based in Indonesia, which is the Minister of Public Works and Human Settlement Regulation number 24. It's the guidelines for the building maintenance as the basis of their research. And the second question, what are the reasons for the corrected and the eliminated activities? Where although they use the building maintenance guideline regulation, the guidelines are still generally accepted. Means that it's not distinguished between the high rise or the low rise and the simple building or the complex building. So it's so general. Meanwhile, the maintenance approach for those buildings can be different. So there are some activities that may not suitable for the simple building condition. As example, one reference mentioned that destructive test maintenance activities for building foundation are carried out every 3 to 5 years. But according to the expert, the simple building does not require destructive tests of foundation that often. So there is a different opinion between them. Some say 10 to 15 years, and some say it's not necessary at all to get the test of the foundation. So the guidelines then corrected to the 10 to 15 years. And then the eliminated example is such as painting acoustic ceiling, which is seem unnecessary because it can actually clog the acoustic pores. So that's a kind of reason why it eliminated or corrected. I hope that's answer your question.
Okay, thank you.
Thank you.
Is there any question? Okay. No question. If there are no more questions, we can conclude the presentation session by Ms. Dia Ayu. Thanks for Ms. Dia Ayu for your presentation.
Yes, thank you very much.
On the fifth occasion, we invite Mr. Johnny Tanijaya as a fourth presenter for the Class B parallel session with the paper title "The Effect of P Delta and P Delta plus Large Displacement Modeling on Horizontal Displacement." Okay, Mr. Johnny Tanijaya, time is yours.
Hello, I'm Johnny Tanijaya from Paulus Christian University of Indonesia, Makassar, Indonesia. I will give a presentation about the effect of P delta and P delta plus large displacements modeling on lateral and axial displacement. Introduction. Engineers need to be more careful and understand the use of the structural analysis program. The assumptions of modeling need to be considered carefully. The effect of changes in geometry due to large deflection cannot be taken into account in the elastic linear analysis. The SAP 2000 program is a finite element-based program. This method solves problems by referred to as meshing. The smaller meshing segment used, the more accurate the output will be. The study was conducted to determine the significant differences in modeling options, such as linear, nonlinear, and nonlinear plus large displacements, as well as the effect of segment division in the analysis. Literature review. There are two types of P delta effect, namely P big delta and P small delta. P big delta is associated with the member ends displacements, while P small delta is associated with local deformation between end nodes. P delta only consider P big delta effect, while P delta plus large displacements consider both P big delta and P small delta. The additional moment resulting from the P delta effect is called the secondary moment or second order moment. Secondary order effect is not presented in linear analysis, hence the nonlinearity option should be activated to account this effect in analysis. Methodology. This picture shows a column is subjected by the compression force and horizontal force. The table shows the parameter model. The horizontal force 1 ton is applied as the final horizontal load, while the final compression force is varied for each model, P1 to P4. These are equations for critical buckling, loading, effective stiffness, and moment of inertia. Results and conclusion. Second order moment. In linear analysis, the same moment is obtained for all cases. This indicates that the moment is only provided by the horizontal force, while the compression force does not give contribution to it. The second order moment increases as the increasing of compression force. It has significant effect for the higher compression force. Lateral displacement versus horizontal force. The curved line is formed as the increasing of compression force due to the effect of geometry nonlinearity, while the straight line is formed for linear analysis. There is no significant difference between lateral displacement of P delta plus and P delta model. However, the difference of lateral displacements is quite significant when comparing between nonlinear and linear analysis. Axial displacement versus horizontal force. The difference ratio of these models are close to 1. This means that there is no significant difference. The gradient line for nonlinear analysis have almost coincide with the linear analysis. This indicates that P delta effect has no significant effect to axial displacement but affects the lateral displacement. Meshing effect. The results show that meshing does not provide significant difference for both P delta models. The ratio are close to 1. Compression force versus lateral displacement. When the small compression force is applied, the line form tends to be almost linear. Then the curved line takes forms as the increasing of the compression force. In linear analysis, the lines form tend to coincide with each other when applied with different compression force. This concludes that the lateral displacement is not affected by the compression force. Local moment at joint. P delta plus effect tends to have more effect for the larger compression force. The ratio increases as the increasing of compression force. Its local joint has different moment ratio. This indicates that the P delta plus effect is taking account for local deformation. Conclusion. The lateral displacement in linear analysis is not affected by increasing compression force. This indicates that the moment is only provided by the horizontal force linear cases. The increasing of lateral displacement due to larger compression force can only be seen when activating geometry nonlinearity option for both compression and lateral forces. The moment for nonlinear case is about 2.4 times the moment for linear case. This concludes that the compression force has significant effect, especially for the higher compression force. The moment of P delta plus is larger than the moment of delta. The difference is about 3%. This indicates that the larger displacement effect takes account to increasing of moment. The lateral displacement is quite significant when comparing between nonlinear and linear model. Therefore, the P delta effect should be analyzed carefully, especially for elements with high compression force. The axial displacement between both models has no significant difference, smaller than 3%. This indicates that the effect only affects the lateral displacement. The meshing does not provide significant difference for both models in these cases. The difference ratio is smaller than 1%. Each local joint has different moment ratio. This indicates that the P delta plus effect is taking account for local deformation. Thank you for your attention.
Okay, thank you, Mr. Johnny Tanijaya. Okay, Mr. Johnny Tanijaya, are you present? Okay. Okay. Direct to sixth occasion, we invite Mrs. Isyana Ratnahapsari as the fifth presenter for the Class B parallel session with the paper title Various Strat Macro Modelings for Infill Frame Analysis. To Mrs. Isyana Ratnahapsari, time is yours.
Okay, thank you, Mr. Putra. Assalamualaikum warahmatullahi wabarakatuh. Today I want to present my paper entitled Various Strat Macro Modeling for Infill Frame Analysis by me Isyana Ratnahapsari, Marwah Yudi, Edi Purwanto, Senot Sangaji, and Stefanus Adi Kristiawan. This paper has a background the masonry infill frame is a common structure for residential building in many countries. The contribution of infill walls should be considered in the modeling to describe the structure response accurately when exposed to earthquake load. And then, one OSAC macro model is the equivalent diagonal strat. First part, we have to describe of model structure, geometry and material use in the existing 2D portal model research by Kakaletsis, like this picture. And the boundary conditions of a model are defined as fixed support. The geometrical parameter and mechanical properties of model structure can be seen in the table number 1 and table number 2. Especially for geometric dimension using a model with a size of 1/3 of the prototype. Based on numerical validation by Sukrawa using straight width EM 2810 MPa. The simplified infill frame macro model divide into 4 phases. Phase number 1, using diagonal strat approach for macro modeling. Phase number 2, how to model the infill frame. Phase number 3, determining 3 main criteria to build on the diagonal strat such as geometrical, mechanical, and empirical parameters. And phase number 4, numerical model with various types of strats. This is the picture that gives information about the, this is the masonry visual in A, and B, detailed definition, geometrical parameter of masonry infill for strat modeling, and C, how to make macro modeling of masonry infill in Seismostrat 2020. And this is the table that gives information about 3 infill model parameters. And second part, numerical simulation. Before we do the infill frame analysis, we have to open frame model validation first. The numerical modeling from Seismostrat 2020 is validated by the result of Kakaletsis. The cyclic load employed in this Kakaletsis study were replaced by lateral load, increased incrementally per 10 kN until the maximum load, setting the displacement control in 30 mm and iteration 50 steps. From the capacity curve, we can get conclusions. The open frame modeling in Seismostrat is comparable to the experimental result. Going into discussion about infill frame analysis. In this paper, we will conducted with several types of infill frame model. Analysis number 1, we using 3 types of diagonal strats: single strats, double strats, and triple strats. And analysis number 2, we do adjustment of EM. EM number 1, we using the experimental result on the Kakaletsis is 670 MPa, and EM number 2, we using 2810 MPa, referring to equation from FIMA 356. And analysis final analysis, we defining various residual strut area or AN2. On this slide, we explain in principle the difference between the strat model. From the picture and formulas, we can see the difference definition, initial strats, and vertical distance between nodes on the strats. This is the result when we use 3 type diagonal strats. We can get conclusion, double strat and triple strat give the closest to the experimental results. And when we use variation of EM, we can get result as presented with conclusion. Value of EM 2810 MPa is more reasonable to use than EM 670 MPa. And when we use the various AM2, this paper we estimate AM2 based on the stiffness degradation of the result from Kakaletsis. Like look at the figure number 7. From this curve, we can find out when the first crack and when the panel has residual strength. It is related to plastic elastic condition as shown in figure number 6. And first crack occur has the stiffness ratio in 78%, and residual strength has the stiffness ratio in 10%. We propose AM2 in the range of 44 until 78%. From this analysis, we can get result of EFDS AM2 with 55% gives the most similarity value of peak load, and EFDS AM2 with 78% shows the closest value of stiffness at peak load. Finally, we can get the general conclusion. Double strut and triple strut model have the capability to estimate the structural response of masonry infill frame because they have model error of the peak load basis in 11 and 16%, and they have a model error on the initial stiffness basis in 35% and 9%. EFDS model with EM of 2810 MPa has smaller model error if compared to EFDS EM 670 MPa. A smaller value of EM increases the strut width, thereby increasing the strength of the structure as a whole. The proposed AM2 is in the range of 44 until 78%, representing a range of conditions from initial stiffness to the stiffness at residual strength. And the last, EFDS AM2 in 55% provide the best estimate of the infill frame behavior with model error 0% based on peak load, and EFDS AM2 78% has model error 2% based on stiffness at peak load. And thank you.
Thank you, Ms. Isyana Ratna Hapsari, for your presentation. There are question? Other question from other participant? Okay. Martiana, I would like to ask Isyana, how did you adjust or model the joint? Thank you.
Okay. Thank you, Mr. or Miss Martiana, for your question. I make model the joint in the Seismostruct 2020, just like setting from the degree of freedom. Degree of freedom is setting rotasi rotate direction X, direction Y, and direction Z. That's all.
Okay. Is the answer satisfactory? Mr. Martiana? Okay. Maybe next. Okay. From Mr. Ibnu Samsi. How do you convert the wall stiffness to struts model?
Okay. Thank you, Mr. Samsi. We can share screen, maybe, Mr.
Okay.
You can see my presentation?
Okay, I can see.
I can try my best a question from Mr. Samsi. Just like this, Pak Samsi. The stiffness of the infill frame is calculated from the lambda H. Lambda H can calculate it with this, with calculation with this. Maybe I try to fit your equation. Wait a moment.
Okay, no problem.
Maybe just the concept or something like that. Not in detail.
Oh, in detail, not in detail. Yes. The proposed model consists of 4-node masonry panel element designed to represent the behavior of infill panel in frame structure. Each panel is represented by 4 strut member, 2 parallel strut in each diagonal direction, and one of strat acting like a shear spring modeling, and have tasks to carry out the shear stress from the top to the bottom of the panel. Stiffness calculated like the stiffness of spring, Pak Shamsi. That's all.
Yeah, okay, that's all. Maybe I'll check the detail in this slide. Maybe.
Okay, thank you.
Thank you so much.
Okay. Any question from others? There's no question. If there are no questions, we can conclude the presentation session by Ms. Isyana. Thanks to Ms. Isyana for your presentation.
Okay, thank you, Pak. You're welcome.
On the second, on the seventh occasion, we invite Mr. Hakas Prayuda as the sixth presenter for the class B parallel session with the paper title Compressive and Flexural Strength Behavior of Banana Tree Fiber Hybrid Concrete. To Mr. Hakas Prayuda, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. My name is Fanny Monica from Universitas Muhammadiyah Yogyakarta. Today I will present the result of our research about compressive and flexural strength behavior of banana tree fiber hybrid concrete. And this is the authors of this paper. And this is the outline. The first one is introduction, and then experimental program, result and discussion, and conclusion. And now we move to introduction. Concrete has advantage including high ability to withstand compressive forces, durable and economical compared to other construction materials. However, one of the disadvantages of concrete is the low ability to withstand tensile forces. Utilization of fiber in high-strength concrete can increase the tensile strength, thereby reducing the brittle properties, which is one of the weaknesses of high-strength concrete. In this research, banana tree fiber is used as natural fiber in the process of making concrete. Examination of the characteristic of fiber concrete using banana tree fiber has been done by many previous researchers. This is because banana tree fibers is easily available in tropical countries such as Indonesia, Malaysia, Philippines, and Thailand. Excessive use of natural fiber in concrete can also cause several problems, especially reducing the durability of concrete. This causes the surface life of the concrete to be shorter. Thus, one method that can be used to increase the flexural and tensile capacity of composite concrete with banana fibers is to use a hybrid system. The hybrid system is fiber concrete that is placed only in the tensile part, while in the compressive part using normal concrete with the same compressive strength planning. In addition, it is believed that the fibers in the concrete do not significantly affect the compressive capacity of the concrete, but have a significant effect in increasing its tensile strength. The properties of concrete using a hybrid system have been discovered by several previous researchers, but have not been found by utilizing fibers from banana trees. And this is an experimental program. The concrete material in this study consists of a binder in the form of cement with the type of Portland pozzolan cement based on ICRMCE 595 and silica fume from PT Sika Indonesia with a classification from ICRMCE 1240, coarse aggregate, fine aggregate, water, cement and N-type superplasticizer, which aims to increase workability in fresh concrete so as to facilitate the processing process, and banana tree fiber. And this is the figure of banana tree fiber. This is a mixed proportion for 1 metric cubic of concrete. The compressive strength test was carried out on cube-shaped specimen with specimen size of 100 by 100 by 100 mm, referring to the ICRMCE 39, while the flexural strength test was carried out referring to ICRMCE 239, with specimen size of 150 by 150 by 600 mm. This is a properties of fine and coarse aggregate, and this is a figure of setting up for compressive strength test for hybrid concrete. On the bottom is fiber concrete, and on the top is for normal concrete. This is result for compressive strength. In figure 4, we can see compressive strength of concrete with different amount fiber. The result of early edge concrete testing at 3 days show that the concrete already has high resistance to withstand compressive forces. This is due to the effect of the addition of silica fume to the concrete, which can increase the compressive strength of the early stage concrete. In the 28-day concrete test, it can be concluded that the hybrid system in concrete does not affect the compressive strength. This can be seen from the result of the compressive test for each variation, which does not have a height difference. However, it is necessary to pay attention to the duration during the casting process of fiber concrete with normal concrete. It is feared that the use of too far a duration between the two types of concrete will result in cold joints in hybrid concrete. And this is a flexural strength. The result of the flexural strength test showed that the increased fiber content results in higher flexural strength and the higher displacement value obtained. It can be concluded that the hybrid system in flexural testing is very effective in increasing the flexural strength of concrete. This is because the concrete is weak in resisting the tensile force, while the fibers are placed in the tensile area, so that the fibers can increase the capacity of the concrete. And this is the conclusion from our research. The addition of fiber to concrete affects the workability of fresh concrete. A high amount of fiber reduces the level of workability in fresh concrete. Hybrid system in fiber concrete combined with normal concrete does not affect the compressive strength value. This is because the fiber is only placed in the bottom area of the specimen. And the high amount of fiber in hybrid system increase the flexural strength of the concrete. This is because the fibers work effectively in resisting the tensile forces that occur during the bending test. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you to Miss Fanny. Miss yes. Fanny, okay. Miss Fanny. From the paper title, compressive and flexural strength behavior of banana tree fiber. Okay. Okay. Are there any questions from this presentation? Okay, Mr. Ibnu Samsi. Oh, Mr. Ibnu is active. This very unique because you use the banana fiber. So my question is, what kind of treatment you did before you use it as the additional material in concrete?
Okay, thank you, Mr. Ibnu. So before we use the fiber of the banana tree, we dry it. To remove the water content of the fiber, and then we coat the surface of the fiber with the resin. The resin is for to make the fiber become waterproof and durable. Yes, that's all.
Okay. From Muhammad Yani. Okay. Definition of the banana tree fiber as 0.08%, 0.16%, and 0.24% is based on weight or volume cement proportion.
Okay. The percentage of the fiber, it's from the weight of the cement.
Okay, weight?
Yes.
How about weight?
Weight of the cement.
Maybe you can share screen.
Okay. Sure.
Okay, I can see.
Yes.
Oh, okay. Based on weight, yeah? Based on weight, cement.
Yes, sir.
Based on weight cement, not based on volume.
Okay.
Okay, from Mrs. Wahyu Kartini, how does the banana tree fiber affect the long term? Because banana tree fiber is an organic material.
Yes, actually, this is our preliminary research, and in the future, we hope we can research about the durability of the banana fibers in the concrete. So for now, to make it durable, we coat it with the resin. But the specimen we testing, it's now just until 28th day. But we don't know how about the quality of fiber if the specimen more than 28 days.
Okay, is that answer satisfactory?
Hello.
Yes. Oh yeah.
Okay.
This is Miss Yaya. She is author of this paper.
Yeah.
Okay.
So this is doing research with Fanny and Hakas, and then I can tell about the long term for the banana tree fiber. I think until now we cannot answer from that because from this research we did have the preliminary research about the mechanical properties until 28 days, and then as we can see, until 28 days, we can get the banana trees durable until 28 days. But for more than 28 days, we need to continue. We need to do some experiment again. Yeah, just that. And then to prevent the fiber until 28 days, we use the resin as the Fanny Monica tell before. Thank you.
Okay, how many resin to clean the banana tree?
Yeah, I think we can for the resin depends on the bananas that we have calculated, because we use the bananas 5 centimeters, and then after we measure about the weight of the fiber, the banana fiber, so we just put it into the resin, so we cannot measure about it. And then we need to make it dry until the water content is 0% before we put it into the concrete mixture. But I think from your question, we cannot we can continue about we can continue the research by using the trial how much the price is. And then for this research, we cannot we I think, yeah, the resin is not measured. We just put it the banana fiber into the resin, just that. But I think it's a good idea,
Okay.
Professor Putra. Thank you so much.
Okay, thank you, Miss Fanny and Miss Martia.
Yeah.
Okay, time is up.
Yeah.
Sorry, I apologize. Okay, next participant. On the 8th occasion, we invite Miss Ida A. Nomleni as the 7th presenter for the Class B Paralel session with the paper title Sensitivity Analysis on the Effect of Reinforcement Materials Addition for Soil Stabilization. To Miss Ida Agustin Nomleni, time is yours.
Okay, thank you, Mr. Putra, for your time.
Good morning, ladies and gentlemen. My name is Ida Agustin Nomleni, and today I would like to talk about the sensitivity analysis on the effect of reinforcement material addition for soil stabilization. This is the content of my presentation today. First part is introduction. The second part is testing procedure and results, and the last part is conclusion. So we are going to the first part, introduction. The civil engineering structure like building, bridge, highway, tunnel, dam, tower, etc. are founded below or on the surface of the earth. For the stability, suitable foundation soil is required. To check the suitability of the soil to be used as foundation or as construction materials, its properties are required to be assessed. Assessment of geotechnical properties of subsoil at the project site is necessary for generating relevant input data for design and construction of foundation for the proposed structures. High plasticity clay is a problematic soil because it has a low bearing capacity, so it needs stabilization to increase its bearing capacity. Several studies have been performed to stabilize high plasticity clay, for example, using a mixture of tire waste, cement, and clay. Research to improve clay properties has been conducted with the general aim is to improve the engineering properties of clay, especially to increase soil bearing capacity and reduce soil compressibility. The increasing number of motorized vehicles in Indonesia has led to increased vehicle tire waste. Based on data reported by the Indonesian Central Bureau of Statistics, there was an increase in motorized vehicles from 2014 until 2017. The increasing number of vehicles has led to an increase in vehicle tire waste. Vehicle tire waste in large quantities can cause various health problems when built up or burned. Therefore, the reuse of tire waste is needed to reduce environmental degradation. One effective way of utilizing tire waste is by using it as a mixture in geotechnical construction materials. Many researchers worldwide have implemented vehicle tire waste. It's because tires develop rapidly throughout the world. In this study, we use sensitivity analysis method. This method was proposed by Lenhart in 2002. Lenhart used the partial wide divide partial age differential approach in determining the sensitivity index value. Using the differential approach showed that changes in output parameters are affected by changes in input parameters. Part 2. Testing procedure and result. A preliminary test aimed to determine the soil properties. In this study, soil was taken from Ploso village, Mojokertang, Karanganyar, at a depth of 0 to 0.5 meters below the ground level. The soil-specific gravity is 2.66 with a liquid limit of 57.94% and plastic limit of 29.31%. According to USDS system, this soil can be classified as inorganic clay or high plasticity clay. The reinforcement material used in this test are cement, tire waste, and water cement ratio for the hydration process. Tire waste has been cut in 1 mm times 1 mm times 30 mm dimension and mixed with soil, cement, and water in various weight conditions. The weight of straight dry mixture varied from 0 to 7.5% of dry weight of the soil mixture. The water cement ratio used in this study are 25%, 35%, and 45% of the cement dry weight. Due to variation of the mixture composition, a wide range of the data is obtained. The data obtained from the unconfined compression test then calculate and analyze using sensitivity analysis. Primary data from unconfined compression test results have been used in this research. The unconfined compressive strength test was conducted on high plasticity clay. This research was conducted under Indonesian National Standard or ASTM designation D163300 standard test methods for compressive strength of multi-soil cement cylinders. And this figure shows that shredded tire waste addition can affect the unconfined compressive strength value. The value of unconfined compression strength without the addition of tire waste is 173.55 kilonewton per square meter. At the addition of 1.5% tire waste, the value was increased, and then the value of unconfined compressive strength decreased by adding 4.56% and 7.5% of tire waste. The sensitivity analysis can be done if the model has 2 or more dependent variables. In this analysis, the water cement ratio of 45% and 20% cement is the dependent variable. Dependent variables are needed to get the simple 3D statistical model for predicting the unconfined compression strength of the model. The first step of sensitivity analysis is determining the value of the addition of the optimum tire waste percentage for adding a water cement ratio of 45% and 20% cement using 3D statistical model. Based on 3D statistical model, we can get the percentage of tire waste that needs to add to the unconfined compression test sample. Based on this analysis, the percentage of tire waste can be found with this equation, and the maximum percentage of tire waste addition is 4.05%. And the second step of sensitivity analysis is determining the sensitivity index for the addition of 3% tire waste for the addition of water cement ratio of 45% and 24% of cement using 3D statistical models. The water cement ratio, cement, and sensitivity index can be plotted with 3D statistical model. And the sensitivity index value can be obtained by using this figure or the equation as follows. The index sensitivity for the addition of 3% tire waste for adding a water cement ratio of 45% and 20% cement is 29.49. And then the third step of sensitivity analysis determines the optimum unconfined compressive strength for the addition of 3% tire width for the addition of water cement ratio 45% and 20% cement using 3D statistical model. The model can also be predicted using the following equation or figure as follows. The predicted unconfined compression strain is 430 kilonewton per square meter with the proposed equation. The unconfined compressive strength values in the model can be predicted using the following equation. The unconfined compression strength value in the predicted model is 399.03 kilonewton per square meter, while the unconfined compression strength value in the laboratory test is 412.40 kilonewton per square meter. And this is the third part, conclusion. The first conclusion is the addition of reinforcement material can increase the unconfined compression strength of high plasticity clay. The second conclusion is the cement proportion is the most sensitive variable for unconfined compression strength from the sensitivity analysis. And the third conclusion is the sensitivity analysis result can help to become the baseline to help design improvement using tire waste strips on high plasticity clay. Thank you for your kindly attention.
Thank you very much for your kindly attention.
Okay, thank you to Miss Ida Nomleni from your presentation. Okay, interesting and good topic, yeah, for soil stabilization. Are there any questions from this presentation? Okay. Okay, from Ms. Fatia, how do we apply this in the field?
Actually, thank you for your question. I want to answer this how to say this improvement actually not not yet applied in the field because it's still under the study, but a lot of researchers now conducted a research in the field to apply this method, but still have a problem, need to study more deeply. But we hope in the future we can apply in this method in the field, in the field, like that.
Okay. Other participant? Any question? Okay, from Miss Fatia Hakim again. Consideration on why do you use the UCT instead of the traction test, maybe?
Thank you for the question. Actually, in the study before, I want to use the triaxial test, but we still have a lot of problem when we want to do the triaxial test because have several limitation in our machine. So I use the unconfined compression test machine to do this test. But actually, I also only want to study the compression strength of these mixing materials instead of use triaxial test data, because if we use the triaxial data, we have a lot of data, and I just want to do the sensitivity analysis, and actually we can get a lot of data, but I just want to apply the sensitivity analysis in the compression strength data only, like that.
Okay. How the condition of tire in experiment? Use or new tire?
Thank you for the question. Actually, I use the old tire after we use after we use, and then I cut into the 1 millimeter and 1 millimeter and 30 millimeter dimension, and I only use the waist tire, not the new one.
Okay. Good experiment and good topic for green construction.
Thank you very much.
Okay, maybe other participant? If there are no more questions, we can conclude the presentation session by Ms. Ida Agustin Nomleni. Thanks to Ms. Ida Agustin Nomleni for your presentation.
Thank you very much, Mr. Putra.
Okay, on the next occasion, we invite Ms. Fatia. It's Sagita Ningrum as the 8th presenter for the Class B parallel session with the paper title Lesson Learned from Weathering Clay Shale Residual Interface Shear Strength Testing Method. Okay, Ms. Fatia Hakim Sagita Ningrum, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. I'm Fatia, and today I'm going to tell you about our paper called Lesson Learned from Weathering Clay Shale Residual Interface Shear Strength Testing Method. So these are the presentation content, which includes introduction, methodology, results and discussion, and conclusion. So first of all, we know that existence of glacial and landslide is very common in Java Island. And some of the cases were the Cipularang Tallwell landslide, Hambal landslide, and the Semarang Bawen landslide. Now, glacial is unique because of its property of swelling and weathering due to its minerals, exposure to water and air, which is weathering, and the decrease of shear strength with the increase of weathering. And glacial is characterized with weathering grades. Now, I'm going to tell you about the Semarang Bawen slope, which is initiated by different strength of soil layer for its landslide. And in this research, we're going to propose the interface weathering method, which will describe the interface shear strength behavior of undisturbed glacial with weathered glacial, and evaluate and offer suggestions for further research. So, glacial samples were taken in undisturbed state from Semarang Bawen Solor, kilometer 483 plus 200. It is classified as Kerek and Kaligitas Formation glacial. The interface shear test was conducted as a single-stage direct shear test until its residual state with 3 normal stresses of 35, 70, and 104 kN per meter square. So the glacial undisturbed were cut into 2 pieces for the upper part of the shear box and the lower part of the shear box, with the upper part is the undisturbed glacial and the lower part is the weathering glacial. And due to the limitation of the device, effect of fissures and forward pressure reading was ignored. So to determine the amount of samples, first of all, we know that we conducted it with the interface single stage shearing. And second, we need to know the effect of water at the interface, which were differentiated into testing the sample 5 minutes after the 8 days wetting drying cycle and testing after 1 day of the 8 days wetting drying cycle. And as previous research by Aldas in 2017, glacial at the similar location would completely weather in 48 days. So the optimum cycle was 2 times soaking period for 8 days wetting drying cycle. And as you can see at the right side of the presentation is the overall flowchart of the interface direct shear test. Now these are the results, which consisted of the cohesion
interface friction angle, and also the average stress ratio. And for the cohesion versus weathering days, values were scattered for both soak and dry conditions, and trend for the soak conditions were similar but with positive value, whereas the trend for dry conditions were different from one another, whereas sample 3 had positive trend and sample 4 had negative trend. Overall, the positive trend means that the increasing weathering days would eventually increase the interface cohesion. For the friction angle, values were also scattered for both soaked and dried conditions. Now, trend for soaked conditions were similar but with positive value, whereas the trend for dried conditions were negative. So after the wetting drying cycle, the friction angle at the interface is higher than after the soil had some time to dry itself. Now, this is the average stress ratio versus weathering days. Average stress ratio is defined as the average of ratio from the shear stress and the normal stress. The values were scattered for both soak and dry conditions, and trends showed positive value, meaning that the average stress ratio would increase as the weathering days increases. Now, these are the R-squared values for the test. As you can see, most of the samples were scattered. Precision was not good. And the reasons for the scattered values might be due to the samples were prepared similarly, but results did not give a similar behavior. Single-stage method might not be the correct method, and theoretically, the shear strength would have decreased as weathering days increases. So the increase in shear strength may be due to the swelling of glacier when immersed in water, changing the shearing interface. And you can see clay would naturally bind the particles as seen in this image. A thin boundary should have been used when testing, and as seen in the image, the top part of the undisturbed glacier was also affected. Here are the conclusions. First of all, values of the interface cohesion, interface friction angle, and average stress ratio was scattered. The trend of both the soaked and dried conditions were random, and the R-squared values indicated that the results of the test had low precision. The positive trends were not in agreement with previous research where the shear strength should have decreases as the weathering days increases. And adverse trends of the result might have been due to the swelling tendency of glacier, which means that the interface might not be tested at the accurate interface, and it might also be tested at the undisturbed glacier or the wetted glacier. And no partition was used in the interface direct shear test, which gives the water to seep through the weathering glacier to the undisturbed glacier. Finally, the single-stage shearing method might not be suitable for the weathering process. So, interface direct shear test for the weathering glacier was not suitable to obtain the objective. Future research should consider the lessons learned, such as first, use the multi-stage direct shear method, second, include the pore water pressure measurement, third is using the thin partition to separate the upper and bottom part of the sample, the fourth is that use separate weathering phase from the interface direct shear test. So, no water intrusion to the upper undisturbed glacier and confirm that shearing will be at the interface. Assalamualaikum warahmatullahi wabarakatuh. I'm Fatia.
Waalaikumsalam. Thank you, Miss Fatia, for your presentation. Are there any question from other participant? Okay, not yet. Okay, how is the R-square of experiment and the model?
Sorry?
How is R-square of your experiment in the model?
Actually, the R-square is just the R-square value from all of the results that from the experiment. So this is the R-square from the Excel, which I used to plot the results from the experiment and then compare it from one and another, because the value is quite scattered. So I need to know whether the results are actually quite accurate or not.
Okay. Are there any question from others? Okay. Okay. If there are no more questions, we can close the presentation session by Ms. Fatia.
So thank you.
Thank you so much, Ms. Fatia, for your presentation. Okay. On the question, we invite Ms. Florentina Pramesti for the Class B parallel session with the paper title Analysis of CO2 gas emissions generated by lightweight passenger cars using IPCC method and direct method. Okay. Okay. Are you present, Miss Florentina? Okay. Okay, the next presentation from Mrs. Win. Okay, Miss Win Lestari with the paper title Fault Structure Interpretation on the Western Part of East Java using Second Vertical Derivative. Okay, Miss Win Lestari, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. My name is Win Lestari. I'm from Institute of
Waalaikumsalam warahmatullahi wabarakatuh.
I'm going to present our research topic about fault structure interpretation on the western part of East Java using second vertical derivative. Here's the outlines. I will start with introduction. It's about background basic theory. Then we jump to methodology. I will inform about the gravity satellite data that we use in this research, design survey and research flow. And finally, I will talk about the result and analysis and conclusion. Okay, figure 1 shows us the tectonic setting of Indonesia. It's very active tectonic zones because the existence of 3 major plates. The data from geodetic show the 1995 and 2016, so all the active Indonesia. And figure 2 show the seismicity on Java Islands that is dominated by earthquakes related to subduction and landfalls, investigated by National Earthquake Study Center 2017. And from GPS measurements, investigated the numerous invention of new active faults throughout the East Java, consists of Kandung Fault, Surabaya, Waru, Gombak, and Cepu faults. And it's our focus on this research because those active faults exhibit several areas with dense population and facilities. Figure 4 display the landfalls on Java Islands, investigated by National Earthquake Research Center 2017. We utilize the gravity methods. It's based on the Newton's law, explain about the relation between 2 masses proportional to the product of 2 masses and inversely proportional to the square of the distance between the 2 centers of masses. Figure 6 show the anomaly gravity that represent the body beneath the subsurface. And this is the filter that we use in this research, second vertical derivative, describe the boundary of the anomaly, and it also can identify the direction of the fault structures based on this formula which is if the minimum value should be lower than maximum value, is normal fault. For the threshold, the minimum value of SPD should be more higher than maximum value. Okay, we use the gravity data from Puppet satellite. It contains free air anomaly data. And we just focus on Lamongan, Gresik, and Surabaya city. Based on the geological map, there is the Surabaya Waru Fault, Surabaya Kendeng Fault, and Waru Fault at the bottom, represented by the red lines. And the stations crosses the active structures. And the areas is about 18 kilometers and 17 kilometers with the distance between stations of 1.8 kilometers. This is the research flow. We start with the extract data from Puppet satellite, and we continue into the data corrections. We reach the complete bug anomaly. It contains region and residual anomaly, which is use the residual that focus on the structure. And we put the second practical derivative in the process and analyze the data. Here is the result. The first, we reach the Bogor anomaly map with dimension 42, 45, 46. And we reach the range of value minus 20.8 till 10.3 milligram. Here's the residual anomaly data, and we lie the information from National Earthquake Research Study, and slightly similar with the interpretation of SPD, represented by the dot lines, and the straight lines is the fault structures. At the top is Baribis Kendeng segment of Surabaya fault, and the bottom is Waru segment. And we continue to slice the profiling perpendicularly with the fault, represent with these red dot lines. Figure 12 shows about the Surabaya Kendeng fault, where the maximum value is smaller than the minimum value. So it shows the Surabaya Kendeng fault is reverse fault structures. And figure 13 is represent the Waru fault, where the maximum value is smaller than minimum value. So we can identify that Waru is reverse fault structure. At the rest, we have conclusions. We can conclude that the result of gravity data processing using SPD 2D modeling have a high level of accuracy. And from the curve of the slice profiling result, Surabaya fault have the SPD maximum value for 0.1 smaller than the minimum value. Then we can identify it with reverse fault as a reverse fault, similar with the Waru fault. Okay, thank you so much.
Okay, thank you, Miss Winstari, for your presentation. Interesting and good topic in the seminars. Are there any questions from this presentation? Okay. Okay, maybe the research is complicated.
Okay, Saputra.
There is no question from other participant. Okay. Okay. If there are no more questions, we can close the presentation session by Miss Win Lestari. Thanks to Miss Win Lestari for your presentation.
Thank you so much, Saputra, and all participants.
Okay, next presenter, Miss Florentina. Are you present? No. Okay. Okay. Finally, Class B parallel session ended. Thank you to the invited speakers and presenters for presenting your research result well. Hopefully, we can meet again at other international seminars. Sorry if there is a mistake in guiding the Class B parallel session. Waalaikumsalam warahmatullahi wabarakatuh. I return this event to MC. Okay, you can back to main room for all presenter. Thank you.